Hello, Honors Chemistry, and welcome to Chapter 8. So, in Chapter 8, what we're going to do is we are going to take what we learned in Chapter 7, which was how to write a balanced equation, and we're going to layer on the math that we can do based on knowing how to write a chemical reaction, right? So really, 7 and 8 are the exact same thing as 5 and 6, just scaled up, right? So, let's talk about what we're going to do. So first, I should have put an intro slide where I could just scribble on, but anyway, I didn't, so we're just going to scribble and then erase. So first of all, if we think about the previous chapter, we talked about molar mass, right? That was one of our new conversion factors. Well, what does molar mass do for us? Right, converts between, this is the number of grams equal to 1 mole of a substance, right? So it converts between grams and moles. We learned about Avogadro's number, which converts between particles equals to 1 mole, right? And those were the two big conversion factors, right? We also talked about how we can relate the piece of a compound to the whole of a compound using either a mole ratio, a mass ratio, or a particle ratio, depending on what we're trying to do, okay? In this chapter, we introduced one new key conversion factor. Basically, everything else is the same, right? All that math we learned in the previous chapter is applicable here, and we will use it. The only new thing, really, is the concept of the mole ratio. Okay, now, this is the only, again, only conversion factor that allows us to convert between moles of A and moles of B, yes? As in, this is the only conversion factor that we've learned to date that allows us to convert between moles of two different substances, right? And note, we're not talking about piece versus whole. We're talking about two completely different substances based on, right, the coefficients from a balanced reaction, right? So this means I have to have the coefficients from a balanced reaction. Which is why, you know, chemistry is cumulative, right? Which is why now, right, if we can't write a balanced reaction, which means we have to be able to write formulas, which means we have to know, you know, all these kinds of things, right? We can't do this, right? So now we're just layering on this. If we need to convert between moles of A and moles of B, mole ratios are how we're going to do that, okay? All right, let's go ahead and do a couple of skill builders, right? This section doesn't have a whole lot, because the concepts are pretty simple, especially after all the math you know how to do, right? So here, what we're doing is not hard compared to what you already know how to do. Just includes one new conversion factor. So, skill builder number 8.2. We would like to, first of all, it gives you a balanced chemical reaction. That's just a crutch for now. Obviously, you'll write your own very soon. But we need to figure out the number of grams that can be produced from 5.5 grams of MgOH2, right? So, thinking about that, one of the things to bear in mind, right, is that we know we have 5.5 grams of this, right? The assumption here, right, is that we have ample HCl, yes? Unless we're told otherwise or the question alludes to something else that we should think about, right now, for this section, right, we have one given, and we can assume that any other reactants are present in abundance, in excess, okay? All right, so 5.5 grams of MgOH2, 5.50 grams of MgOH2, and I would like to talk about grams of HCl. Is that right? Did I write that right? I think I did. I would like to know how many grams of HCl. I need to react with that, right? So, if I want to talk about the relationship between, if we label this A, and if we label that B, that means at some point I need to do a mole ratio, which means that I need to be in, right, units of moles. So let's go ahead and what's going to convert from grams of MgOH2 to moles? Right, molar mass, right? So I need to get the molar mass of MgOH2. Next, now that we're at moles of MgOH2, now we can do our mole ratio, which says that for every 1 mole of MgOH2, right, 1, the understood coefficient there, there are 2 moles of HCl. Finally, right, we know that 1 mole of HCl, what's this last conversion factor called? Right, molar mass. So 1 mole of HCl has a mass of 36.46 grams of HCl, right? And then when we go back through here, we see that grams of HCl cancel, moles of MgOH2, and we've converted to the right unit, and so probably our work is right, and then we just need to type it in correctly. Yes, makes sense? All right, let's do the next one. So here I would like to know the number of kilograms of H2SO4 from 2.6 times 10 to the third kilograms of SO2. So again, right, if I think about this as being A and this as being B, at some point I have to do a mole ratio, okay? So we're going to start with our 2.6 times 10 to the third kilograms of SO2. And then, step 1, right, let's get it to grams. SO2 is equal to 10 to the third grams of SO2. And next up is, right, molar mass to get from grams to moles. So for SO2, 64.06 grams of SO2 for every 1 mole of SO2. And then, right, then we're going to go with our A to B, right? So every 2 moles of SO2, we would produce 2 moles of H2SO4. And then, last step, right, molar mass again, right? 1 mole of H2SO4 is equal to 98.06 grams of H2SO4. And then we would convert to kilograms, where 10 to the third grams is equal to 1 kilogram. Okay, now if we're talking about canceling, right, kilograms, kilograms, grams, grams, moles of SO2, moles of H2SO4, grams of H2SO4, right? We will also see, right, that 10 to the third cancels down here, 10 to the third cancels up there, these 2's cancel. So then the actual amount of math you're typing in is actually quite small, right? So there's not a lot to type in there. But anyway, now we've worked 8.3, we just need to type it in correctly. Yes, makes sense? All right, so key here, right? 1, you still need to know the conversion factors from the previous chapter. 2, right? Once we have our balanced equation, we just need to figure out what's our A and what's our B. And then we know that if there is an A to B conversion, we need to do a mole ratio, right? So do what you need to get to moles of A, do your mole ratio, and then take it to whatever unit you need for B, okay? And obviously we'll incorporate conversions that we've learned previously, like from chapters 2, as we continue working. All right, thank you for listening, and be good, and I will see you soon. Bye.